Good times. It was a nice break. I had to Google map how to get back to school today. It was so, it's like, oh, that's right. School. I remember that. Where was that at again? But we're here. Let's look at our cybersecurity lesson for the week. We just got 3 weeks and then that finals week, which is only 3 days long. So we don't have much left until we get a nice long break. Looking forward to that too. But we'll finish this up strong here. Let's go to our cybersecurity class. Go to our grade screen, see where we're at. All right, before the break, we had 3.02. As you can see, we just got 2 lessons left and then our final exam. So we're about to get this wrapped up. We're talking about authentication today on 3.03. So let's go check that out. Authentication lesson right here. Eventually. Hey, there it is. All right. You can't come in. Oh, we have one of those things where you put the sign up in our bedroom when we're little, right? You got brothers and sisters, don't come in. Identification, authentication, authorization, accounting, IAA. That's a system used to describe the framework for controlling access to computer resources. Big part of cybersecurity, right? Allowing only valid computers and people to access the network. Different resources, controlling usage, implementing procedures. These are considered the foundation of effective network management. Absolutely, right? Who should be able to access this file? So identification creates an account or an ID that identifies who the user is. Right, which device you're logging in on, or the process on the network. What you're just trying to ID. All right, who's trying to access this file? This process is used to verify legitimate users. That makes sense. Cybersecurity, you want to make sure it's legitimate. Some cases, this is where the billing and delivery addresses must match to prevent fraudulent payment methods. Maybe that's what they're checking. Oh, the person that is placing an order or trying to access something, is that really the right person? Does the billing address match? Authentication. This validates the user's identity by asking for specific information. That's where they have like a password or a fingerprint or something to say, okay, looks like you're the right person because your ID matches, but tell me the password if you're really that person. That's the first major step in access control, and that should be met before you go any further. Don't let you see anything inside the system to provide, and that's very common to us. Passwords are part of life, right? Authorization. This allows the users to perform certain actions like accessing, editing, and saving files. So a lot of times, maybe your access only allows you to view something. You can't make changes when you get in there. So this allows users in the system with access files to make changes if you're authorized. Authorization. That determines where the user has the right to go when you get into the network. Okay, you're allowed to be in the network. I've authenticated you, but let's see what you're allowed to do when you get in there. So types of users might include administrators, power users, standard users. Administrators or admins run the show. They're the ones who make all the changes to the system. They decide who can access the resources on the network. Power users are typically employees who tend to have a lot of access. Right? They can access more things, maybe supervisors and stuff. Standard users are usually business partners or vendors, right? Maybe the vendor can log into your system, but they're not an employee, so they can't place orders or change things sometimes without going through an employee. So they just have access to view things and see what they've done in the past, see past business transactions or whatever it is. So their authorization may be different than an employee's authorization. And then finally, the accounting part. This measures the overall access of the users by tracking the amount of information they access. We can go see what have they done, what did they go into, what did they see, what resources they consumed, number of hours they spend on a session, how long were they logged in, what did they look at while they were there. Everyone's actions are visible on a network, right? This holds users accountable for their actions. If something goes wrong or if data is leaked, management administration can track the issue to who got into that data, who had access to it, who actually looked at it, and so figure out maybe who leaked it. So the IAAA system. Types of authentication. So let's talk about it. Passwords are the basics, right? That's what we see most commonly on everything. Once a user enters the username, they're prompted for a password. Just like we did to get into Buzz, we had to give our password just to access this lesson. The problem is cyber criminals have ways of uncovering these passwords and getting access to sensitive information. Absolutely. I had cyber criminals hack into my wife's email that she doesn't use as often anymore. And then they were able to go and ask for new passwords on different websites that were attached to that email. So since they had access to email, they went and reset passwords because it sent a reset link to that email. And she didn't know it because she didn't check that email very often. So I had to go back and recover about 10 or 15 different websites that she lost access to when they went in and changed her password. Once I got control of the email address again. So it's important to choose secure passwords with a combination of letters, numbers, and special characters. Not generally words found in a dictionary, right? Because that's what people would try first. The longer the password, the better. 1, 2, 3, 4, 5, 6 is not very good. Password called password. A lot of smarter systems won't even let you use password as a password. It'll say not valid. Won't let you use that. But there's a lot of them that aren't very good. It'll let you do that. Even the strongest passwords are at risk. There's really not a password that's unhackable. At some point, somebody's going to get in there because they're using the computer to try to break into it. Two-factor authentication is a lot more popular these days. That's where you enter your password. And if it's a brand new computer you haven't logged in before, you'll get a message on your phone. Is this you trying to log in? Yes. Because you put your phone number into that. So that's the way to verify, yes, this is me. Go ahead and let me in. Because just because someone has the password doesn't mean it's actually someone that should be in your account. So that's what that two-factor authentication. So sadly, that's having to be used more and more just because of all the hackers out there. So it adds another layer of security. It could be something different, like a smart card with something another PIN, a different second password, something. Think about an ATM card and a PIN number. That's a second two-factor authentication. First, you have to have the ATM card. That's your first level. And then after you have that, you have to have a PIN number on top of that. Three-factor authentication adds another layer. Like could be a location-based factor like GPS coordinates. So it says, well, you've got the right password and you've done the secondary thing, but this computer's in Nigeria. That's not right. This person does not live in Nigeria. There's never been a login from Nigeria. That could be a third factor authentication, which I would really appreciate if a lot of more websites would use that. So if they can see somebody's hacking in from somewhere else in the world, that they could stop that. So let's see. There's several types of technologies for defining credentials. So let's categorize those. Something like a password, something you have, like a smart card, something you are, like a fingerprint. My wife uses fingerprint to get into her computer or her tablet. Something you do, like write a signature, because it can compare how you sign your signature, because people write differently. So if I tried to sign your name, it would look so much different. It would say, this is not a valid user. It wouldn't let me in. And then somewhere you are, like a mobile device with location services. It's like, you don't live there. That's odd. And authentication, that's a fun word to try to say, product is considered strong if it uses more than one layer, right? That's what we really need nowadays. Single factor systems offer little or no security. It's easily compromised. Here you go. Here's a did you know? Yahoo admitted in 2013 there was a data breach that affected all 3 billion accounts on its server. All of it. I have a Yahoo email. I mean, mine was exposed too. I don't put anything important in my Yahoo email. Exposing the private information of users whose accounts were encrypted with what was ultimately weak security. At the time, this was the largest data breach in the history. Yeah, 3 billion people. That's pretty big, right? They reached the $117 million settlement due to sensitive information that was taken, like emails, passwords, birth dates, security questions, contacts. All that was breached. 3 billion accounts. Their security got a little tighter after that. Yeah. It gets expensive. Password hashing and authentication. In the early days, computers' passwords were stored in databases like plain text. I mean, if a user wanted to sign in, the application would ask for the password. And if it was equal to whatever was stored in the database, no problem. No problem. So as the internet grew, cyber criminals discovered ways to gain access to those databases. So they could just get all of the passwords. They'd hack in and get it without you having to get anything from you. So network administrators needed a better solution. So they invented password hashing, which is a password is turned into a scrambled representation of itself. So that other website that you're logging in, it has your password, so it knows if you're right, but it doesn't save it as a password. It scrambles it, but it knows how it's scrambled. So it has to decode the password and compare it to what you typed in. So that way, if someone hacks in and steals all those passwords, they still won't know what the passwords are unless they knew how they were scrambled. Humans have been sharing secret information by translating it for thousands of years. It's called cryptography, right? The process of creating written or generated code that allows information to be kept secret. Code. All right, I'm going to add 2 to every letter. So A equals to 3, B equals to 4, C equals to 5, and I'll just send you a bunch of letters. You got to decode it. That's the same thing. The science of secret communication. That's the basis for hashing. Hashes enable a computer to verify the password without storing the password the way it was typed. Hash functions can be used to authenticate messages on both ends. The message is locked up, but it goes through the key goes through a transformation on the receiving end to use as a deciphering tool. So here's like a hashing algorithm. Maybe the username is AC3D2E1, but it may store it like this. Woo, that's quite an algorithm that changes that. Maybe it changes it to ASCII code or something. Oh, what's this little link here? Is it just make it bigger? Oh, text version. You enter the password, the username and password, and it's passed to an algorithm. It makes this really long thing when it's stored on their server. Of course, cyber criminals are always looking for an opportunity, so even hashed passwords are at risk. Modern password hashing algorithms combine passwords with a salt, which is a random string of data. So identical passwords produce different hashes. See, that'd be interesting. The same password won't produce the same hash. So the output of the hashing function is mixed with the salt and hashed again and again, and maybe thousands of times, which makes it very expensive because you're using a lot of processing time. But each pass through the salt and hash routine is called an iteration. So the higher the number of iterations, the harder for the password cracking computers to generate those matches. Gets very complicated. The more complicated hacking gets, the more complicated we have to get in stopping it. 802.1x authentication. This is an IEEE standard for port-based network access control. So only users who pass through this type of authentication are given access to the network. This ensures the safety of the internal network. It uses a client-server structure, consists of 3 parts: the client, the device, and the server, the authentication server. So the client has software installed on the device. The device is an access device like a laptop or a tablet in which it has 802.1x authentication enabled. And then the server has a service for the device that implements the authentication, authorization, and accounting on the users. So here's a little drawing to illustrate that. So you have all of these over here, goes in from the cloud. All the access goes through this authentication switch. So these computers have to go through here and authenticate before they can access each other and access the cloud and other things. So here's a user. The user comes right into here. The first thing it hits is the switch. Before it can access any of these other things, it's got to be authenticated. How is it used? Let's see. In a wireless network, 802.1x is used by an access point to implement WPA, Wi-Fi protected access. That's a security protocol designed to create secure wireless networks. So to connect to an access point, a wireless client must be first authenticated using the Wi-Fi protected access. In a wired network, switches use the 802.1x to implement port-based, based on the port that they're connected to. Before a switch forwards packets through the port, the attached devices must be authenticated. And after the user logs off, the virtual point being used is changed back to the unauthorized state, right? Because they don't want someone else to be able to access the same port and already be authorized. So since someone logs off, it deauthorizes it. So the benefit of that is the switches and access points themselves do not need to know how to authenticate the client. All they do is they pass the information between the client and the server handles the actual verification of the credentials. So the switch sends it on to the server right there that authenticates it for it. So that supports many different methods of authentication, from username and passwords to hardware tokens, challenge and response, digital certificates, all of that stuff. Virtual hands-on. So throughout this course, you'll have the opportunity to apply what you learn using a virtual lab environment. Ooh, we don't have a load of virtual to lab stuff here, but we don't have the lab connected on there. Let's go here and see what we got. Oh, let's see. Let's see if we have that. What is? So we do have the questions, right? The 5 questions. Yeah.
Yeah, and the 3 open-ended at the bottom.
Yeah. Do that. If we have access to a lab, I'll let you know. But I think we just have the questions this week. So have a great week, guys. We'll see you next time.